Hello and welcome to the Section 6.1 lecture today. Today we're going to be starting our last unit of this microterm, so I think it'll be a little bit shorter of a unit. I think we only have 3 sections, and we will try to get it done pretty quick so that we can kind of get ready for next microterm. All right, so today we're talking about measures of center. And the idea behind measures of center is kind of trying to find what the middle of a data set looks like, what kind of the overwhelming or overarching kind of, well, not to overuse a word, but the average, what the balancing point sort of is. So let's go ahead and get started. The mean is probably most known as what we would typically call the average. Okay, it is the really what we consider to be the weighted average of the data. And how it's found, typical way of finding average. Add all values and divide by the number of values. Okay. The next one is the median. Okay, the median is what I consider to be the true middle number. Okay, it is the middle number. So when you, if you look at all the numbers from smallest to biggest, it's going to be the one or kind of ones that are right in the middle. All right, and how we find it, we I'll say sequentially order the numbers. And then kind of count off until we get the middle. I'm going to call it that, to count off to the middle. Okay, so we're trying to find that number that's right in the middle of the ordered set of numbers. The last one is the mode, and we kind of think of that as the most common. Most common number that shows up. Okay, and for this we just look for the most repeated value. Can't spell today. Okay. All right, so for this first data set, I want to find the different averages. I want to find the mean, the median, and the mode. We have a big set of numbers. It might help to know exactly how many numbers. So let's go ahead and count them kind of in a way that's going to help us a little bit. So 1, 2, 3, 4, 5, 6. And there's 3 rows of 6. So that would be 18 plus 1. There's 19 total numbers. And when you're dealing with statistics, the number of numbers is typically saved as n. It's technically the population size. So there's 19 numbers. And then if we want to talk about adding all the numbers up, we use a Greek letter for that called sigma. It looks like a funky looking E. And we'd say sigma x, so that means the sum of all the x's, okay, or all the values that we have. For that, I'm just going to use a calculator and punch through these. So we're going to look at 15 plus 7 plus 13, 6, 12, 19, 15, 13, 15, 8, 5, 6, 14, 6, 5, 6, 5, 15, 19, 13, 10, and 13. We get 240 as our sum. So then when we talk about the mean, we're talking about the average. We put a little X with a line over it to mean the average is going to be 240 divided by 19. Most commonly, this number is going to be a decimal. Okay, and we get 12.6, meaning that the weighted average of all the numbers is 12.6. And so that's the mean. Not too bad. For the next one, the mode, this is where the work kind of comes in. I need to order my numbers from smallest to biggest. I need to make that sequential ordering. The smallest number that I see is a 5, and I have 3 of those. So 5, oops, that's a 6. So 5, 5, 5. Okay, then I have 1, 2, 3, 4 6s. So I'll put those down. 1, 2, 3, 4. I have 1, 7. So I'll put that one down. I have 1, 8. So I'll put that down. It looks like I don't have any 9s. Okay, I have a 10. And I don't really hesitate to cross this list out because I'm just remaking this list right here. Okay, so remaking this list is going to help me out. Don't have any 11s, but I do have 1 12. And I'm going to kind of go over into my mode here a little bit, but that's okay. 13s, I have 1, 2, 3, 4 of those. 1, 2, 3, 4 of those. It looks like I have 1 14. 15s, I have 1, 2, 3, 4 of those. And then 2 19s. All right. Now to find the median, I want to count off one by one from each side until I get to the middle. A lot of times if I'm doing this on a piece of paper, I might cover up the numbers sequentially from both sides just with my fingers. Here I'm just going to underline one from each side. So there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, there's 8, there's 9, there's 10, and then I have 2 in the middle. That doesn't seem right. 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 22. How to get 22? 1, 2, 3, 4, 6, 7. Okay, so there is 22. So my mean is off. That's lovely. There were 7 in each row, not 8 like or 6 like I thought. So let's go and recalculate our mean. 10.9. And this brings us to an interesting part when we're talking about the median. The very middle of these numbers is technically in between these two numbers. Because I have an even number of numbers, that's why it's going to happen. That's why I felt like something was off. Okay, but it actually My list is good. It was my previous calculation that was off. So when we're looking for a median between two numbers, we're going to take the average of those two numbers. Okay, and on this one, you probably don't really have to do it. We're technically looking for the middle point between these two numbers, which it probably won't shock you what it is. 12 plus 13 divided by 2 gives me 12.5. So the median is 12.5, which is halfway between 12 and 13. Okay. For mode, I'm looking for the most common number. I see that I have 4 6s. I also have 4 13s and 4 15s. So typically we save the mode for the one number that's repeated the most. In this case, I have 3 numbers that are repeated the same amount of times. So I list all 3. 6, 13, and 15 are all modes of this set of data. Okay. All right, let's look at the back, see what we're doing there. Hopefully we don't make any silly mistakes. So the next one, it says, why are these all used as averages? I'm really looking for why or when. Guess why. Why are these? So the mean's used as an average because it's a calculated average, a calculated weighted average. That uses all the data points. The mean is used as an average because it finds the middle of all points. And then the mode is an average because it finds the most common value. Which, again, those are kind of just going back to the definitions, but it is important to realize when and why you would use certain averages. So looking at this data set kind of brings us to kind of see some different ideas of these different averages. So I want to find the mean, the median, and the mode of this data set with salary ranges or salary amounts of different workers. So we have a sales rep or an executive sales rep, a couple sales reps, sales administrator, secretary, CEO, a couple cooks, and a kitchen administrator. So just looking at what we have our population wise, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 people. We would say n equals 10. The sum, as I'm trying to find the average, is found by adding all these up. 23,000, 25,000, 25,000, 20,000. Oops, let's start over. 26,000. Nope. 23,000. 25,000. 25,000. 20,000. 58,000. 12,000. 12,000. 12,000. And 25,000. So the sum of all of them is 238,000. And so if I divide that by 10, it's going to give me the average, the mean, as 23,800. Then for the median, I want to order these. Now I'm going to knock off the thousands on these just to make them a little bit quicker to write, which is all I need at this point. I kind of needed the thousands when I dealt with the average, when I dealt with the mean. I need to stop saying average. So this is one of them. To order them, I have three 12,000s. I'll just use K's for 1,000. So three 12,000s. Just going to put dots here to notify myself that I've dealt with them. I have a 20,000 would be next. 23,000 is the next one. I'm actually going to scoot these over a little ways. Probably still won't fit them in, but that's okay. 1, 2, 3 25,000s. And then a 26,000. And then a 58,000. Okay, so I had to deal with two rows here, but that's okay. We can definitely make that work. Let's go ahead and count our way in from the outside. There's 1, there's 2, there's 3, there's 4, and it would be right in the middle of these two, which is going to be 24,000. If you add those up and divide by 2, you're going to get 24,000. Okay, so that's the median. And then for the mode, it's the most repeated, and I have 2 of them. My pen's lagging out really bad. I am not happy with that. Okay, we call this set bimodal because it has 2 numbers that are repeated the most, and that would be 12,000 and 25,000. Now, when it comes to really talking about what the average would be, the main things that we want to look at when we have numerical data are the mean and the median. Give us the best averages. Okay, a lot of times when we're dealing with salary ranges, a lot of times the median's a little bit better, because something like that 58,000 that the CEO makes is so much more than everybody else that it almost pulls that average up. But that being said, our median was right about 24,000. So you know, if you get a job here and if you work as long as the people that are making these amounts work, you can expect to probably make somewhere around $24,000 a year. Especially looking, bringing in the mode a little bit, seeing that there's a lot of people, probably new people, at the line cook position and even the secretary position that make a little bit less. So probably newer people are making sort of more towards that 12,000 number, and more seasoned people making towards the 25,000 number. So it does take looking at all parts of the data to get a good idea, but that's really what we come up with. So make sure you get any questions that you have over on the left. Otherwise, I hope you have a great day, and we'll see you in class.